Nuclear bombs are weapons of immense destructive power. They are entirely different from conventional bombs or explosives. Not only did it unleash devastating destruction on the ground, but it also spewed deadly radioactive dust tens of kilometers high into the atmosphere. Nuclear bombs operate on the principle of fission to generate energy. A fission reaction occurs when neutrons bombard the atomic nucleus. This process releases an enormous amount of energy while emitting extremely lethal levels of radiation. After a series of experiments, scientists concluded that uranium-235 and plutonium are the two most ideal elements for achieving nuclear fission. Because nuclear bombs generate energy through a chain reaction of nuclear fission, the more reactions occur, the greater the destructive power. According to reports by American scientists, the US currently possesses approximately 5,500 nuclear weapons, while Russia has around 6,000. However, modern weapons today possess destructive power 20 to 30 times greater than the bombs dropped on Hiroshima and Nagasaki. If the US and Russia simultaneously launch all the nuclear weapons in their arsenals, it could be a catastrophe that ends human civilization. The terrifying destructive power of nuclear bombs stems from multiple factors, among which the explosion creates a massive fireball. The victims near the center of the explosion were completely incinerated by the extreme heat, reaching millions of degrees Celsius. Afterward, the shockwave was unleashed, causing destructive tremors that leveled houses within a radius of several kilometers. The supersonic winds carried flames and heat from the bomb, forming firestorms that incinerated everything in their path. The nuclear explosion creates a dust cloud along with radioactive particles the size of sand grains, spreading into the atmosphere, known as nuclear fallout. Inhaling this type of dust can cause radiation poisoning, damage body cells, and even lead to death. Atmospheric dust can block sunlight, leading to a sudden drop in temperature and shortening the growing season of vital crops. Crop yields may severely decline for decades, leading to widespread famine. If a 300-kiloton nuclear bomb were to strike a city the size of the U.S. capital, Washington, D.C., many residents would not survive, while those nearby would also sustain severe injuries. A lethal dose of radiation would spread across most of the city and even a small area in Vornia, located more than 200 kilometers from the blast's epicenter. Thermal radiation and intense heat will spread to areas of Maryland within a 40 kilometers radius, extending slightly farther to Vornia. Those within a 35 kilometers radius from the blast center will suffer third-degree burns. According to experts' estimates, just one nuclear bomb could kill approximately 300,000 people in the Washington area and injure many others. Depending on the density of the bombs and the destructive power of the explosions, the death toll could be even higher. The more powerful the weapon, the greater its destructive force, much like how the blast power of a nuclear bomb also depends on the detonation method. If the attack is carried out with a land-based weapon, the explosion will disperse more radioactive dust as soil, rocks, and other materials are blasted into the atmosphere. But if a country detonates a bomb in the air, the shockwaves from the explosion will hit the ground, reflect, and amplify each other, causing far greater destruction. According to the Environmental Protection Agency, this aerial explosion could also propel radioactive materials up to 80 kilometers high into the atmosphere. Nations often rely on simulations and weapons testing to predict consequences, but in reality, it is extremely difficult to accurately anticipate how a nuclear attack would unfold in today's world. This is unprecedented in history, as nuclear weapons have only been used once in war, during World War II. The two atomic bombs dropped by the United States on Japan in 1945 remain the first and only use of nuclear weapons in war to date. May it also be the last time humanity witnesses such a tragedy. The first bomb, named Little Boy, was dropped on Hiroshima with a destructive force spanning approximately 13 to 18 kilometers, creating a 6 kilometers high mushroom cloud and releasing radiation into the air. The bomb instantly took the lives of 80,000 innocent civilians in the city. The second atomic bomb, named Fat Man, was dropped on Nagasaki just one day later, with even greater destructive power than Little Boy. Unlike the previous bomb that used uranium, Fat Man released energy from plutonium, creating a horrific explosion with a blast yield of up to 21 kilotons. The explosion formed a mushroom cloud over 8 kilometers high and claimed the lives of 40,000 people. Although the two American bombs used demonstrated terrifying destructive power, Humanity has since developed thermonuclear bombs with a force thousands of times greater than Little Boy and Fat Man. The Soviet Tsar Bomba is the most devastating weapon ever detonated by mankind, with a power equivalent to 50 million tons of TNT, or 50 megatons. This test could be observed from up to 1,000 kilometers away, producing a mushroom cloud 64 kilometers high. Notably, the pilots involved in dropping the bomb during this test had only a 50% chance of survival. If a 100 megaton nuclear bomb were to detonate directly over a city, how devastating would the consequences be? First, the bomb will be detonated at an altitude of 14.5 kilometers above a city to maximize the destructive force of the blast's shockwave. Its core will reach a temperature of approximately 100 million degrees Celsius, 4 to 5 times hotter than the sun. An extremely hot gas sphere will form, exploding outward at speeds of millions of kilometers per hour, compressing the surrounding air around the fireball, creating a shockwave of immense size and energy. The fireball will reach a diameter of up to 6.1 kilometers. The intense heat and blinding light from the explosion will instantly incinerate an area spanning 32.6 kilometers, equivalent to nearly 3,350 square kilometers. Thermal radiation can cause third-degree burns within a radius of up to 160 kilometers, covering a total area of nearly 26,450 square kilometers. Just seconds after the explosion, fires several kilometers from the epicenter will erupt violently. These fires will generate massive hot air currents rising upward, drawing cooler air from surrounding areas toward the blast center from all directions. Strong winds will cause the fire to spread rapidly and gradually merge into a single large flame. The energy released from this massive firestorm would be 15 to 50 times greater than that produced by the initial nuclear explosion. This firestorm will rapidly intensify, incinerating a massive volume of air before surging upward at speeds of nearly 480 kilometers per hour. This chimney effect will draw cool air from the surrounding areas into the fire's center at speeds of up to hundreds of kilometers per hour. These superheated ground winds are stronger than hurricanes and extremely violent. They are so powerful that they can uproot trees over 1 meter in diameter and even suck people standing outside the fire into the flames. These terrifying winds can reach temperatures of hundreds of degrees Celsius. Within a few dozen minutes after the explosion, a massive firestorm will completely incinerate everything within a radius of 32 to 73 kilometers from ground zero. The burned area around the explosion's epicenter spans up to 3,350 square kilometers. Within 3 to 6 hours, the firestorm will rage violently, with average air temperatures in the burning area reaching 200 to 260 degrees Celsius, incinerating everything in its path. With that devastating force, the death toll could exceed 8 million, including those fortunate enough to find shelter in the deep basements of sturdy buildings. They could also suffocate from the oxygen in the air being burned away or be roasted alive if their shelter heats up like an oven. The flames will consume all life and level nearly everything within their reach. Finally, the radioactive dust began to spread, destroying the habitat.